Over some of the homework problems from 5.5. And so the question actually was more than just checking convergence. It was deciding which of these three cases we are in: absolute convergence, conditional convergence, or divergent. Okay, and so this means always two things that have to be checked. First, you have to step one, if you want, let me write it like that, is the alternating series test. Of course, we do this because we have alternating series. We shouldn't do this if we don't have them. Okay, and then what does that mean? That means that you take the limit of this series. So we have this series, this is the general term, but we ignore the signs. And that's the limit we take. Okay, so the limit of radical n plus 3 over n for n going to infinity. Now, you might want to do the L'Hopital here, because infinity of rim, but with these radicals, I told you already before, it doesn't work well. And so the best technique here is with the technique that we always have been using when we're doing some rational expressions or radical expressions like that, is divide by the highest degree term. Okay, don't confuse what we do next. You'll see it's a bit similar but not the same. So what's the highest degree here? Well, so on top we have radical n, but in the bottom we have n. Right? Because remember, the radicals we have to take as part of the determination of what the highest degree is. So the highest degree is n here. So we're going to divide everything by n. So divide this by n and divide this by n. Okay? So what does this mean? What does this mean? Well, that is. But the problem is now, how do you carry out this thing? Well, there's only one way to do that, is bring the n inside the radical. But if you want to bring it inside, it becomes n squared, right? Because if you take this n squared out of the radical, then it becomes this n, okay? And in the bottom, of course, that's just 1. And now we can carry out this limit here, because if we now divide everything by n squared, we get 1 over n, the first one, and the second one gives 3 over n squared. Remember, we have to divide every term here over 1, that's ridiculous to write, right? And so now plugging in infinity, both of these guys goes to 0, and so the result is 0. Now, is that a good thing? In this case, yes, it is. So this means that the alternating series test holds, so the conclusion is already, from step 1, we get convergence. But that's the second letter here. What about the first one? Okay, so this is now, the step 2 is determining whether we have actually absolute convergence. So AC, that's what we're after. And this means that, again, we ignore the sign, but we now not take limits, but we look at the series itself. Okay, so this means, let me write down what that means, is we are talking about this series. So in other words, forget the previous series, concentrate on this one. What is this? Well, we see this is limit comparison test, right? And now, remember, so this is the limit comparison test that we'll do, which itself has several steps, okay? So I'm not going to list the number anymore, but the first step was to determine what Bn was. And for that, we had to look at the highest degree on top, which we already discussed was radical n, and the highest degree in the bottom is n. Notice now we don't take the biggest, we take whatever is biggest in top and whatever is biggest in the bottom. Okay, so you notice the difference between this, what happens here, what happens there. Okay, why? Because here we're making a choice. Previously we were taking a limit. Okay, so but once we have done this thing, then the next thing was to calculate the limit of an divided by bn, and that we did by dividing the top of an by the top of bn, and then the same in the bottoms. Now in the bottom that all cancels out, and in the top, now we don't have to worry about putting things in denominator in radicals. They all are in radicals. So we get n plus 3 over n, and in the bottom we get, as we already said, 1. Okay, so this limit, we just carry out the division inside. It's 1 plus 3 over n. That is 1. Radical 1, 1. What does that now mean? Is this good or bad? Well, in the limit comparison test, the only thing what we need is not 0, not infinity. So yes. So it means convergent. No, it means this is a good choice. So now look at Bn. So look at this Bn and determine what it is. Because this is now a p-series. So, and let's write it as a p-series. That means, first of all, I should write it as exponents. And it has to actually be written with exponents in the bottom. So that would be a power 1 here, right? So 1 minus a half is a half. So p is a half, which unfortunately is less than 1. So we actually get divergent. So conclusion, it's not that, because this is divergent. So finally, the final answer is we have conditionally convergence. Okay, so 265. Let's do the next one. That was summation minus 1 n plus 1 n to the power e 1 plus n to the power pi. Now you might say, what, we are powers, but that's okay, we can do any power here. These are still look like p-series. I'm not saying they're p-series, but they look like p-series, okay? So again, step 1, we have to calculate the limit where we ignore the sign. This means this. And by the previous, it's exactly what we did before, except perhaps we do now have to deal with powers that look unusual. But what's the biggest here? Well, on top we have n to the e, in the bottom we have n to the pi. Now what is the biggest? Well, which has the biggest exponent? E is 2.7, pi is 3.4, so we're talking about this guy, right? Okay, so we're going to divide everything by n to the pi, top and bottom. Okay, so what does that mean? And go to infinity. Well, the powers cancel, and we have n to the pi minus e, right? Why do I write it? You might say, why do you write it this way and not the other way around? Well, what's the highest power? Pi is the highest power, right? So I know that this is a positive power, okay? And so here we have 1 over n pi plus 1. And the whole thing is now, if you have a positive power and you plug in infinity, you get 0. So 1 over n to the power p, the limit of this thing is infinity. Well, this is if p is bigger than 0, if it's a positive power. If it's a negative power, it's not at all, because then the negative power makes it a reciprocal, and then it would actually be n, but then you would see that the limit would be infinity. So that's why I'm choosing writing it reciprocals, and that's why I chose the biggest power, so that both these exponents are positive, meaning that if I plug in infinity, they will go to 0. And so what I'm left with is 0 over 1, that is 0, which is what we want. We need 0, and that's the only thing we need there to get this, to verify the alternating series test. So this was the alternating series test, I should have said that, right? Okay, but that's not enough. We need to see what happens. Step 2. Well, it's the same, right? So now we ignore again. So this is the AC, right? Ignore this, the plus or minuses, and we look at this. Same as before. We find out what Bn is. We know now what the powers are. It's n to the e over n to the pi. So we do the limit again. Limit for an divided by bn. So you see, what looked very weird is these powers n and e. It's really not. Just think of them as just, okay, they could be 2, but it's not 2. It's 2.7, and pi could be 3, but it's not. It's 3.14. So what? What is the big deal? Okay, so limit and go into infinity. So n to the e, this guy divided by this guy, which is of course just 1. In the bottom we get something a little bit more calculation. Okay, so this cancels already, we said, and so what we get is a 1 on top, and then I have a 1 plus n, 1 over n to the pi plus 1. Oops, that was a bit too much. Okay, and as before, since this is a positive power of n, this goes to 0, we plug infinity, so the whole thing is 1, and what matters is it's not 0 infinity. That's not the end of the story. What we should now look at is Bn. What can we say about Bn? Well, it is NE over N pi. The P series wants us to write everything into the bottom, so it's pi minus E. So P here is it's a P series. I didn't write down last time, but I said it right. P is here pi minus E. Now that actually is a number less than 1. Just put it in the calculator. 3.14 minus 2.7 sounds less than 1, right? So this means again divergent. So conclusion, one more time, this is CC, not AC. And then the last one, that was the 266, I guess. Yeah, let's do this one. Number 266, the limit for S going to infinity, minus 1, n plus 1. Yeah, you might say, why do you always put n plus 1? I have no idea. There's no real reason to do that, but that's what they did. Okay. I mean, you could have write minus 1 to the power n. It would be a different series, but that's good. That would go on to right. So step 1. It's again an alternating series, right? That's of course the thing. Be careful now. We are in this topic of alternating series, but soon we will talk about anything, and then we have to be. You can only use these alternating series tests. It's very important when you have an alternating series. Why would it be called otherwise like that, right? So the alternating series test. That means I have to take the limit for n going to infinity, ignoring now the sign, so of this guy. Okay. Okay, so let's plug in 1 over infinity, that's actually 0, and so 2 to the power 0 is 1, right? There's actually not really much going on. It looks like a difficult limit, but it actually is not, because 1 over infinity is 0, right? We can plug it in, and if it works, fine. Why not? 2 to the power 0, that's 1. So what does this now mean? Is this good, is it bad, whatever? No, it's bad, because it's different from 0, so we get divergent. This had to be 0. Now what about step 2? Well, that we don't need this anymore, right? We know it's divergent, so forget about absolute convergence. So this was actually the easier case, so to speak. Okay, I'm going to post separately a review of the quiz for next time. Will be next Tuesday will be on this exactly same topic, absolute convergence and conditional convergence. And exactly the same questions. So in my review, I will just put a few more, but this is already, if you want, a review of quiz number 4. But I'll put something more extra on there.